question is, if a rock is dropped into a water well and
this is a rate one.
approximately 16 to the power of 2 in t seconds, 16t to the power of 2 in t seconds, as a splash is heard 3.5 seconds later, and the speed of sound is 1,087 feet per second, what is the height of the well?
I'll let you take that one.
Simple enough. All right. So I'm going to just, draw a well, obviously. It'll look a lot like my cylinder from yesterday and maybe my can from last year. That's my well. Maybe I'll just make it brick or something. Now it's a brick well.
It's like sticking out of the ground.
Yes.
I'm going to critique your well.
Oh, fine. Here.
Sorry.
No, it looks like water.
It's not supposed
All
to be
right,
water.
here.
That's
There's
a great
grass
well.
around it.
Looks fantastic.
Oh, I like
Happy
that.
now?
I'm in. I'm happy now.
All
yeah,
right.
that looks great.
It's a well in a grassy field. It's very dangerous. You can't even tell it's there, actually. So I'm sure a child will fall in there at some point. But anyway, it's on
not
private
funny.
property.
I'm
so
not laughing.
Don't,
Sort of funny.
All right, so a rock is dropped into a water well. So there's some water down here in the bottom, and I don't know why you can see it through the side of this well. Science.
Science.
So a rock is dropped, and I'm going to have to kind of think through this a little bit. So you got, some kid over here, and he drops a rock, and the rock falls in. The rock is dropped into a water well, and it travels approximately 16 t squared in t seconds.
Inches.
So I'm
What do you
wondering that
see
too.
inches?
It seems like there's no units for the 16.
16t squared.
T squared is time.
Right.
If the splash is heard 3.5 seconds later, and we're saying 1,087 feet per second, so I guess we could say feet. What is the height of the well? And we can mess around with this, but we can actually find the height of the well by saying,
No, what the?
what is the height of the well? Okay, so it splashes in the water, right?
Right.
I actually think the 16t squared in t seconds is kind of irrelevant.
Well,
we
does
say
it mean
it's-
in 16 seconds? T is 16. Is that what it's trying to say?
Okay,
It
here's what I'm
would
thinking,
hit the water.
Is that's gravity. Gravity travels at 16 feet per second. So that's why I'm assuming it's 16.
But what I'm thinking is, if the splash is heard
Right.
3.5 seconds later, yeah, that is the typical
That's
for
gravity.
the
That's the rate of
calculus.
gravity.
Yeah, but I don't think we need that. If
You
it
think
says
you can
if
work
the
backwards from the speed of sound?
yeah, if the splash is heard in 3.5 seconds later, that means
Sure,
Well,
that would
that
be.
it
That's
takes-
all you
Going
really
down
need
at
to know.
16 feet.
yeah, but I think
But
it's
just
irrelevant. Look,
the sound just traveling up.
if the
right, in
sound is
3.5
traveling
seconds.
up and sound is green in this case, at a rate of 1,087 feet per second,
And the well is just super deep.
and it took 3.5 seconds to hear it. So you're standing up here, you drop this well. Oh, because it has to fall down first. So how long did it take to fall down, and then
Yeah.
the sound travels up?
Right.
Okay.
So the rock is going at that rate, and the sound is going at that rate.
Yeah, and I'm assuming that this is feet then, right? So maybe it's something like f of t, like there's some information missing here, equals 16t squared. And then we're saying that what are we saying?
Sorry, we're trying to, there's like a typo or something in the problem, and that's what we're trying to figure out. We're trying to figure out what did they mean? What did the user mean?
Well, we know how
So-
many feet it traveled up.
Yeah. Well then, I mean, wouldn't the distance be the same?
But the time that it took to hit the water is the question. And I think the problem with this, like the way this is presented, is typically what we see is we don't know 16t squared is what? Is that relating it to, is that like the height related to time?
So T is your time in seconds, it looks like.
Right, so typically the way these are written is you have like h of t or something where it's the height, and then it's
And
related
then you
to
find
time.
the derivative.
So when
It's
you
a calculus
drop,
problem.
and you actually don't need to find a derivative, because we're not looking at velocity, we're just looking at this. So let's see. So typically the way we see these problems is you like throw a ball in the air. When is it going to hit the ground? And we see this
Right.
quadratic, right?
Right.
But if we're just dropping it, we have something that's, speeding up as it falls until it hits terminal velocity or hits the water or something to stop it. But we don't really know what this 16t squared is related to. Like, what are we relating time to the bottom of the well?
I'm
or
not sure.
position?
I'm not sure because it's telling it's. I don't know what. 16t squared is that distance. Like, what is that? The problem doesn't really refer
So
to
we're
that.
given an expression, but we're not given like what it is.
What
set
it's
to.
representing. Yeah,
Right.
is that representing distance? I guess maybe let's just do this. Let's, if this is your question, because there's some sort of typo or not enough information in this one, I think, and we did try to figure it out, but we can't say with certainty what that really means. So if this is your question, and you really do still need it answered, contact us and send us a little bit more information, or call us. That would be great. And that way we can interact with you over the problem, because with the way it's written, we don't have enough information right now. So we're not going to try and just speculate and solve it. Call us and we'll work on that for you guys. So I guess that being said, maybe we'll try to find another question of yours to answer. So Darren, is there anything else maybe that we could?
It's too bad because I really like this problem. It's got
I
those
know.
2 layers that usually aren't added.
And
with,
your
like, the
well
down
is
and up.
beautiful.
I spent a lot of time on my art.
I mean,
but,
you could just come up with some numbers. We could just.
yeah, I can
We'll think
actually
of
probably
something that
find
works.
something
Yeah,
similar really
maybe
quick.
go
but,
back to it, but
for now, so we're not
well,
just talking about how we
call
don't have
us.
enough information. and
right.